court last night and you were playing mad nice, man. So I was just trying to learn too. So teach me.
Oh, you trying to learn?
Yeah, I'm trying to learn.
So you're trying to get the ball like this and just straight buckets.
Oh yeah.
So you got it, you know. Yeah.
See, teamwork.
Yeah, teamwork.
Yeah.
It's not true. But why are you playing basketball?
Well, I mean, I just saw a shot last night and I was like, I gotta get me some of those skills. So I'm trying to get better too.
Let me show you how it's done. Hold my papers. Bah!
Make that? Bro, that was quick. How'd you do that?
I'll show you. Okay, so if you look at the calculus problems, what you do is you think of the ball as a particle. Give me the ball. It's a particle, right? And you just have to use a sinusoidal equation for the velocity. And so the trajectory will always go in.
Yeah.
Bro, I didn't even know calc was even that useful.
Yeah, that's crazy. Shout out to Miss O.
Yo, let me show you on the papers. Okay, Safru, you wanna know why I always get that ball in the basket? You use calculus. Imagine the ball is a particle. For 0 to 9, a particle moves along the x-axis. The velocity is given by v of t equals sine pi t over 4. The particle is at position x equals -4 when t equals 0. Okay, go to the math. So, think of the basketball as a particle, and the velocity of the basketball is shown by sine pi t over 4. So what you want to do is find when the velocity is positive. So when the particle is moving to the right. The particle is moving to the right when the velocity is positive. So you have to find when the velocity changes sides. So it has to equal 0 for that to happen. So sine pi t over 4 equals 0 when t equals 0, t equals 4, and t equals 8. So what you have to do is just plug in numbers for the velocity between 0 to 4, 4 to 8, and 8 to 9. When you plug in the numbers, you get v of t is greater than 0 for 0 to 4, v of t is less than 0 for 4 to 8, and v of t is greater to 0 for 8 to 9. The particle is moving to the right when v of t is greater than 0, so when t is between 0 and 4 and 8 and 9. Part B, you just have to find an expression to find the total distance. Now all you have to do to find the total distance is just take an integral from 0 to 9 of the absolute value of the velocity. So, that's the expression. Part C of the problem asks you to find the acceleration at t equals 3 and then decide whether the particle is speeding up, slowing down, or neither. And so what you have to do is take the derivative of the velocity equation, and what you get is pi cosine pi t over 4 all over 4. And so you just plug that in, the 3 into there, and you get a of 3 equals negative root 2 pi over 8. And because this is negative, that means acceleration is negative. And because we've already established that velocity is positive during this time period, that means that the particle is slowing down. For part D of the problem, we have to find the position at t equals 3. To do that, we just take an integral from 0 to 3 of the velocity equation. What you get is 2.174 units, and the initial condition is x equals -4 units. So you add that to what you get from the integral, and you get the position of -1.826 units, which means the particle moved 1.826 units to the left.
Hey man, that was enough basketball for one day. Yeah.
I say we go get some drinks.
Yeah,
I'm tired.
Yeah, I'm tired too. Man, I can't wait to get this high calorie drink in me, man.
It's not good for you, bro. You should just drink water. It's healthy things.
But I mean, I just worked out, played basketball. I mean, burned enough calories.
It's got a lot of sugar and calories and bad things for your body. You shouldn't put that in your body. Drink water. It's the truth.
I mean,
listen, man. I'm just gonna leave. You're grown. You can make your own decision.
Sasha, why are you drinking that super unhealthy drink?
I mean, I just play high intensity basketball with Shashank, man. I deserve to pleasure myself.
Okay. Do you know at least how much you drank?
I drank half of it, but yeah, I just filled up the cup to the top before.
Wait, so the cherry was fully submerged the first time?
Yeah, the first time. I mean, there's still a little bit in there.
There is some in there. So you drank it all, and then you refilled it.
Yeah.
Okay, so now the cherry's only partially submerged. Using calculus, we can find out how much volume of liquid you drank both times. The diameter of this opening and cup is about 8 centimeters, and this is a half a hemisphere, wouldn't you say? And the diameter of the cherry, about the same cherry, is about 2 centimeters. Let's do this. Calculus time! Okay, Sasha, let's find out how much volume of liquid you drank. We can use this for calculus problem to do that. A cocktail glass with a bowl shaped like a hemisphere of diameter 8 centimeters contains a cherry with a diameter of 2 centimeters. If the glass is filled to a depth of HCm, what is the volume of the liquid that it contains? Okay, to solve this problem, we have to make two equations for circles. X squared plus y squared equals 16, and x squared plus y squared equals 1. Then we have to translate them, and we only really need half the circle. So the equation for the glass equals g equals square root of 16 minus the quantity of x minus 4 squared. And then for the cherries, the square root of 1 minus the quantity of x minus 1 squared. We can use these two problems to answer part A and part B and find the liquid that he drank in the first and second time. For part A, we have to consider the case where the cherry is totally submerged. To do this part of the problem, we have to find two volumes. The volume of the liquid around the cherry and the volume above. To find the volume of the liquid around the cherry, you do pi times the integral of 0 to 2 g squared minus c squared dx. This shows the washer method, where g is the equation for the glass and c is the equation for the cherry. Then you have to add pi times the integral of 2 to h g squared dx, because it's just the volume of the liquid in the glass above the cherry, where h is on the interval of 2 to 4. You end up with an answer of volume equals pi times the integral of 2 to h g squared dx plus 37.7. Okay, now we have to do part B. Oh, Sasha, why did you have to drink it twice? You know Shashank's gonna be so angry. Consider the case where the cherry is partially submerged. For this, it's way easier. Volume only equals pi times the integral of 0 to h g squared minus c squared dx. And h is only on interval 0 to 2 because the cherry is only partially submerged and the diameter of the cherry is 2.
Chose to drink it, didn't you?
Yeah.
I can tell.
I feel fat, man.
I know you do. I told you not to drink it. I told you to drink water.
I just made the wrong.
It's alright. You gotta work out now to burn it off. Leave me at the gym. Alright, listen, man. You made a bad decision by drinking that. It had a lot of calories, now you're gonna get fat. Now you have to pay the consequences and work out to burn it off. Alright?
How long?
24 minutes on the exercise bike, and you're gonna go hard the whole time.
I shouldn't have drank that.
Sasha,
Yo, what's up?
well, why are you working out?
I just drank this drink and it had an bad amount of calories, man.
Okay, how about we use calculus to calculate the amount of calories you've been burning this whole time and the rate that they're burning too. Okay, Sasha, let's talk about calories. The rate...
I think I got this one, so the rate in calories per minute at which a person uses an exercise machine burns calories is modeled by the function f of t, whose graph is given by f of t is equal to negative t cubed over 4 plus 3t squared over 2 plus 1 on the closed interval 0 to 4. The remaining portion of the piecewise function is depicted using linear segments on the closed interval of 4 to 24. Okay, so part A asks us to find f prime of 22, indicate units of measure. Since we know t is equal to 22, which is indirectly between 20 and 24, we know that f prime of 22 is equal to f of b minus f of a over b minus a, and by plugging in each number and looking at the graph, we get 15 minus 3 over 20 minus 24, and we get that it simplifies to negative 3 calories per minute per minute.
Wow, Sasha, I didn't know you would remember that.
For part B, the time interval, closed interval 0 to 24, at what time t is f of t increasing at its greatest rate? Show the reasoning that supports your answer. The greatest rate is the largest slope, and to be increasing at the greatest rate, we know that the slope has to be positive. And the only intervals on the graph that we can see this at are from 0 to 4 and from t to 16. From 0 to 4, f of t is equal to negative 1/4 t cubed plus 3 halves t squared plus 1. And take the derivative of that, we get negative 3/4 t squared plus 3t. Take the second derivative of that, we get negative 3 halves t plus 3, and if we set that equal to 0, we get t will equal to 2. So we know that's the maximum at that point. If we take the first derivative of the equation now we found, and we put t equals 2 into it, we get that the slope for the average slope for that portion of the graph is equal to 3. Now going to the second time interval that the slope is positive, 12 to 16, if we take the derivative of that by doing f of b minus f of a over b minus a, we get that the slope is 3 over 2. Now, since we can compare both slopes, we see the average slope on that time interval, the first one, 0 to 4, is 3, and the second one is 3 halves, so now we know that 0 to 4 is greater than 12 to 16.
That must be where the greatest rate of change is, Sasha. Good job.
Okay, thanks Soham. For the next part, for C, we have to find the total number of calories burned over the time interval, the closed interval of 6 to 18 minutes. To do that, we take the integral from 6 to 18 of the function f of t dt. And to do that, we need to take the area under the graph between 6 and 18. And if we divide the graph up into different functions, we get that the total area underneath the graph is 132 calories. Part D asks, the setting on the machine is now changed to that the person burns f of t plus c calories per minute. For this setting, find c so that the average of 15 calories per minute is burned during the time interval 6 to 18 minutes. Well, we take the integral of 6 to 18 for f of t plus c dt is equal to 15, and to find the average we do 1 over the time interval, which is 1 over 18 minus 6. And by using part C, we know that the integral is 132 calories divided by 12 minutes, which is the average time, and we get 11 calories per minute. And since we know we want to hit 15 calories per minute, and the last one was 11 plus C must equal 15, meaning C is equal to 4.
I don't get weak in the knees, honey spread like a fan, prefer like some Gucci sand, open this pack, get a hand, toss them up like a vandal.
Oh, 24 minutes, stop. Yo, Shaq, I can go home now, right?
Go home? Go home. Did you really just say that?
Yeah.
We're just getting started. Let's go for a swim now. Get off.
Swim? We don't even have a pool.
Pool? We're going to that lake back there.
Oh my god. Which way's the pond?
Pond's all the way back there, but you look a little tired. Maybe we should stop and get a drink.
Yeah, I think this time we'll make the healthy decision.
So, I'm glad you learned from your previous mistakes. You're choosing to drink water this time. Put the hose in, the water's filling up right now. Hold up. Is that a puddle? I think this is leaking.
That's weak. I mean, it doesn't seem too bad. I mean...
Oh, Sasha, why is the storage tank leaking?
I don't know why it's leaking, but can't you analyze?
You are the calc guy, right?
Yeah.
Can you tell us
Analyze it.
how much water's in it?
Yeah.
Okay, so using calculus, since we know that the rate that the hose is putting water in it is given by a function, and that the rate of the water leaving is constant for a certain period, I'm assuming that because the water is getting higher quicker, that it's going to change the expenditure over time. But it had 5,000 gallons at the beginning. We can determine the rate that it's entering, the rate that it's leaving, and how much water is in at each time. Let's go to the calc stuff! The amount of water in a storage tank in gallons is modeled by a continuous function on the time interval 0-7, where t is measured in hours. In this model, rates are given as follows. The rate which water enters the tank is f of t equals 100 t squared sine root t gallons per hour for 0 to 7. The rate at which water leaves the tank is g of t equals 250 for 0 to 3 and 2000 for 3 to 7 gallons per hour. The graphs of f and g, which intersect at t equals 1.617 and t equals 5.076, are shown in the figure above. At t equals 0, the amount of water in the tank is 5,000 gallons!
Alright, so I got this. How many gallons of water enter the tank during the time interval 0 to 7? Round your answer to the nearest gallon. To find the amount of water entered, we'd have to take the integral of the rate that the water is entering. So we'd have to take the integral from 0 to 7 of 100 t squared sine root of t. The answer to this would be 8,264 gallons. Okay, now for part B. For the closed interval 0 to 7, find the time intervals during which the amount of water in the tank is decreasing. Give a reason for each answer. The amount of water in the tank would be decreasing when f of t would be less than g of t. This is especially true on the intervals 0 to 1.617 and 3 to 5.076. On these intervals, the water level decreases. Okay, now for part C. For the closed interval 0 to 7, at what time t is the amount of water in the tank greatest? To the nearest gallon, compute the amount of water at this time. Justify your answer. The critical points of the function f of t minus g of t include t equals 0, t equals 7, and t equals 3. At t equals 0, the water is at 5,000 gallons. At t equals 7, the water is at 4,513.8 gallons, which we can find by doing the definite integral of the function f of t minus g of t. At t equals 3, the water is at 5,126.6 gallons. For this reason, the water is greatest at t equals 3 hours when the water in the tank is about 5,127 gallons. Here. You're gonna do 3 laps, then we're gonna call it a day. Alright? Yep. And I'm gonna be sitting there and watch you do it. Good luck.
Session, why are you swimming?
It's part of my workout. It's mad cold, man.
Oh man.
Splash.
I bet we can just find out how cold it's been over the last 15 days.
Yeah, man, it's really cold. Man.
Yeah, we can just find that out from the town. Because it's a lake in a part of the town. So we'll find that out, and then we'll use calculus to determine all kinds of stuff about this pond.
Yeah.
Get out of there, let's go. Alright, let's find out what the temperature of this pond is.
I got this. The temperature in degrees Celsius of the water in a pond is a differential function W of time t. The table shows the water temperature as recorded every 3 days over a 15-day period. Alright, part A. Use the data from the table to find an approximation for W prime of 12. Show the computations that lead to your answer. Indicate units of measure. To find W prime of 12, we would do f of b minus f of a over b minus a. This would lead us to the answer of -1/2 degrees Celsius per day. Part B. Approximate the average temperature in degrees Celsius of the water over the closed interval 0 to 15 days using a trapezoidal approximation with subintervals of length change in t equals 3 days. For this problem, we would use the trapezoidal sum, which is 1/2 x times b1 plus 2b2, so on until the last base. After we got the answer using the trapezoidal sum, we would multiply the whole answer by 1/15 to find the average, which would give us an answer of 25.1 degrees Celsius. Part C. A student proposed the function p given by p of t equals 20 plus 10te to the negative t over 3 as a model for the temperature of the water in the pond at time t, where t is measured in days and p of t is measured in degrees Celsius. Find p prime of 12. Use appropriate units and explain the meaning of your answer in terms of water temperature. As we are given that p of t equals 20 plus 10te to the negative t over 3, we can find the derivative of this function, which would give us p prime of t. After we find this, we would plug in t equals 12 to find p prime of 12, which would give us negative 0.549. For this answer, this signifies that at t equals 12, the temperature is decreasing at 0.549 degrees Celsius per day. Part D. Use the function p defined in part C to find the average value in degrees Celsius of p of t over the time interval 0 to 15 days. To solve this problem, we would multiply 1 over 15 times the definite interval from 0 to 15 of the p of t function, which would give us 25.76 degrees Celsius.
Yesterday was crazy. We did so much stuff.
Yeah, man. Think about it. Calculus is kind of fun.
I was about to say the same thing, man.
Yeah, we should call up someone. Let's do some calculus right now.
Yeah, I was for offense. Yeah, I got it. Let's go call someone right now. Oh, so home? Yeah, me and Shashank were like, yo, yesterday was kind of fun, and we kind of wanted to talk to you again. Like, do you want to hang out today or something?
Yes, sure. Let's hang out and do calculus.
Okay, sure. You want to meet up at your house?
Yeah, let's meet up at my house at 3:14. Get it? Pie.
Okay, yeah, sure. Me and Shashank will be there at 3:14 then. Okay, bye.
Perfect.
I saw you in court last night, and you were playing Mad Knife, so I was like, could you help me out? Like,
Oh, you trying to learn?
yeah, I'm trying to learn.
Oh, so basically you just gonna get the ball like this, you know what I mean? Just straight bucket, you know?
Go.
What up, man?
Yo, what's up? Yeah, I heard you're mad nice at basketball, man, and I'm just trying to get better too. So,
Oh, you
like,
trying to get better? You
yeah.
wanna learn?
Yeah,
Alright,
I want to learn.
basically go get it like this and just bucket, you feel me?
Oh, Sashu, why are you working out?
Yo, I just drank some mad
Water's in it at any given time. So we started with like 5,000 gallons before this thing started leaking, right? Yeah. Okay. So I'm guessing as the volume increased, that it was more pressure on the bottom, and at certain points, the expenditure of the water became a little bit faster. So after a few minutes.
Go!
Do it again, I didn't get it. Do it again.
Oh my god, I can't believe he's actually doing it again.
Yo.
Oh shoot, I got...
Ready? Alright, go.
You need some oomph. I need oomph.
Come on, your inner weird nerd. Proud nerd.
Alright, fine.
With the face.
Yeah.
And the glasses, too, preferably.
Oh yeah, that's why the glasses were on his head. That's why.
Not like in the things, you're like mad loud.
Yeah, like you're nerdy and proud.
Alright, ready?
Okay, so sure. On the part of, so for part A, we have to consider the case. Nah, not you. Okay, so to find the volume of the liquid, we have.
couldn't even say anything. You flashed the light. That's why.
My bad. Old flash.
Old flash.